Welcome to the shop. I'm continuing to make NQALHA parts, and wow, it sure does take a long time to make 750 parts. So I better get going. This part that I'm making today is going to be a lot of hogging out of material. I'm starting with a 1-inch thick block of material that is going to end up being a shell about, I think, I don't know, 90 thousandths, 90 or 100 thousandths thick around. And so the entire inside needs to be hogged out. And I'm going to be using the aluminum shredder from Lakeshore Carbide, the 3-flute serrated flute solid carbide roughing cutter. And in the case of trying to cut a very large, very deep pocket in a piece of solid aluminum like this, especially a small piece, the real problem that needs to be avoided is you got to have proper chip evacuation. And that's one of the things that I really like about the aluminum shredder, is that it produces really fine chips, and the really fine chips are very easy for the flood coolant to evacuate, and I don't have problems. With imperfect chip evacuation, possibly using a different geometry cutter, different feeds and speeds, different type of cooling, making a deep, large pocket like this might be a problem. If chips start getting caught in the cutter, start welding onto the cutter, things get too hot, cutter breaks, ruin the part. So you got to kind of be careful with this. This is a known trusted tool path that's been run many, many times in the past. And as usual, in the progress of this project, the very first production run used a slightly different tool path, and little bit by little bit over time, I've been optimizing it. This particular tool path is using the Bobcam advanced roughing, which is very similar in its essence to the tool paths used in adaptive machining and high-speed machining, and it seems to work really well. So it's a known trusted tool path, run many times before. Z0 is set on the top of the blank, Z0 is set on the top of the tooling plate for the second operation. The third, fourth, and fifth operations are going to involve drilling a hole in the sides of the part at various different angles, and is going to require a special fixture for that. But we got a lot of work to do before we get to that operation, so I'm gonna load up the cutter, do the standard careful preparation here, hand on the stop button, and sure enough, it seems like I'm making this mistake more frequently since I started doing videos. I'm going to make sure the proper cutter is loaded. The PathPilot control software displays a list of the tools required for the job. And, well, I thought I got it right, so this really doesn't have that much complexity in it. So here goes. Going to try it again. Hand on the stop button, finger on the stop button. Tool is loaded. Single block mode. Looks like it's stopping in the right place. And we are ready to go. I'm doing a kind of a spiral ramp in, and The toolpath is basically a variation of spiral and circular cutting action. Probably kind of hard to really see what's going on because of the flood coolant. This is going to be a fairly long operation, so I'll probably either speed it up, or definitely, if I don't speed it up, I'll only show it once, because this seems to take forever. This is going to be what I call the hand control body. It's where the push buttons and the rotary encoder, which is a rotary encoder, is an electronic component that translates rotational motion into electrical signals, and that's what the thumb wheel speed control on the NQALHA is based on a fairly high quality optical encoder. There's always a temptation to use El Cheapo components, but given the importance of speed control on the NQALHA and the fact that I'm trying to make a premium machine, I chose a kind of a top-end component as opposed to an El Cheapo component. Pretty boring. And if you think this one is boring, wait for the next one. The next one coming up will be the controller enclosure, where the little custom circuit board that runs the NQALHA, where that little circuit board fits. And it is, without a doubt, the most complex part in the entire set of parts. Takes a really long time to machine, and it's also a deep cutout in a piece of 1-inch thick aluminum, resulting in a very complex part with very thin walls. So the combination of the fluid coming out of the nozzle and the hydrodynamic forces generated by the cutting produce quite a turbulent pool of liquid, and that further helps to evacuate these fine chips produced by the roughing cutter. When the operation is over and the liquid, there's a hole drilled in the bottom, actually 3 holes drilled in the bottom. When the operation is complete and the liquid drains out, there's no chips left in the cavity. All of the chips are being evacuated out of the cavity by the generous amount of flood coolant kind of turbulently moving around at high speed. And that completes the roughing operation. There's a little bit of, okay, gotta go put another cutter in, T6. Okay, got the correct tool loaded by hand, so I'll have to take it out at the end of the cycle, but we should be able to complete the finish operation. This is going to be a 1/4-inch end mill, and it's a long end mill with a longer cutting flute because the finish operation in this pocket is going to be 0.9 deep. The thickness of the closed part at the end is only 0.1. So there we go. It's going to prompt me to manually remove the tool. And I'm going to drill a couple of holes here using the stubby drills. So got to be very careful about, I'm pretty sure I measured enough stick out, but I'm still going to throw my old eyeball on and get down there and have the finger on the stop button, and all is well. And as the liquid drains out, there are no chips from the roughing operation remaining. A few little chips from the drilling operation remain, but chip evacuation was really excellent on this. And that completes the first operation. So because the roughing pass takes such a long time, that's probably the only time I'm going to show it. And after I do another a couple of parts to get my sequence right, I'll turn the camera back on and show one outside pass, then finish the run of parts and show the drilling operation. So see you later. I'm switching now that I have 2 of the first operation parts done. This one is deburred, ready to go on the tooling plate. The other one is sitting on the paper towel, waiting to be deburred. Got another blank in the right vise. Gonna go over here and load up on the tooling plate. So this is what the first operation looks like, and you can see that very deep pocket, a very constricted space in there of the very deep pocket. And the tooling plate has a couple of 3/16 precision pins pressed into precision holes, and I've got a little screw here with an aluminum washer to avoid boogering up the surface, and part fits nice and tight. Grab my unscrewifier. So now I'm in full production, what I call the combo tool path, that does a first and second operation with one load cycle. Doesn't really do anything about tool change, but it does minimize the number of times that I have to blow the coolant off and open the door. So the combo tool path has also not been run today, so I'm going to be a little careful with it. And given how boring the roughing operation is, I'll probably just speed up the video like really fast, because even I don't want to watch that. That concludes first operation of the combo tool path. Now I need to start paying attention again, make sure that I get a proper tool change and that all is going well. Moving to the correct work offset, I've loaded up a 1/2-inch 3-flute end mill here for doing the roughing. I don't have a 1/2-inch aluminum shredder, so I'm using just a regular 1/2-inch 3-flute Lakeshore Carbide Zirconium Nitride coated end mill. The reason I'm using the 1/2-inch end mill, there's actually 2 reasons. I'm going to be milling a 1-inch face, and I want the stiffness, I don't want the tool deflection, and the 3/8 end mill doesn't have a 1-inch cutting flute. So that's 2 reasons. That is looking good. The roughing pass will be done in multiple the roughing cut will be done in multiple passes. Reasonably slowly at 30 inches per minute. When I try pushing even though when I look at the spindle power meter, it's not, well, there it goes. That part, that was pretty much at the limit of spindle power, so I'll take back what I was going to say about when I tried speeding it up, I ran into chatter problems, because that's about the limit of the 1.5 horsepower spindle at 5,140 RPM that the Tormach is capable of doing. So looking like it's doing a really nice job. This is one of the slowest parts to make in the entire set. Of course, the next ones that I'm going to be making are even slower, but after that, things are going to get faster and easier. I'm almost done with the difficult parts, and the remaining parts are going to end up going pretty quick. And then the final pass, the finish pass, will be full depth, 15 thousandths depth of cut, 30 inches per minute, and it'll produce a very, very nice cosmetic finish. This is one of the parts on the NQALHA that it's almost like the first part you see, it really catches your eye. So it's important that it be very cosmetically nice. Now I'm cutting the relief, which is the area where the thumb wheel is going to go. Doing the roughing operation first. Sometimes it kind of gets boring just standing here watching the machine, but I've been having problems with the tool changer, and I think that boring as it may be, I'm better off standing and watching, just in case something goes wrong. So there, we have now turned a fairly large chunk of aluminum, and oh, forgot my tool change again. Need to tap a couple of 632 holes. So Tool 23. That's what happens when I have too many things going on at one time. Making parts, doing videos, going upstairs to help my wife figure out why the oven went crazy. So this is going to be a 632 tapped hole, and you might wonder why I didn't drill the hole in the first operation. Well, it kind of doesn't matter, but it kind of does matter, because the first operation makes the pocket and makes the holes in the bottom of the pocket. Then the part goes over to the fixture, and actually what I was about to say is not relevant, but I'll go ahead and finish my thought just so I don't end in the middle of a thought. The fixture is good, but it's not perfect. And so if it was important to ensure that the holes were correctly aligned relative to the outside, which will be important on the next part that I do. And actually, having said that, I do the other part in the wrong order anyway, so I'm just getting off on a crazy tangent here that's probably almost meaningless. But what I was trying to say is, if I was making a part where the outside surface and the hole, I wanted to keep them in alignment, I'd make the hole and the outside surface in the same clamping, because there's maybe a few thousandths of give in those two little pins, although they're pretty darn good, and not exactly sure why I set the thing up this way now that I think about it. Tap magic. Memory is weird. Can't trust memory. .632 tapped hole, which isn't the smallest hole I power tap. I actually power tap 440s. Reliably and successfully on this machine. So I'm going to take the part out and show how almost all of that blank got turned into chips. There's the part, and what a absolutely beautiful surface finish. Just love that surface finish. So I'm going to go ahead and run the batch and turn off the camera and see you later. The next operation that I'm going to be doing in parallel on the Bridgeport while this guy is cranking away and making parts, I kind of turned off the process because it's loud and it's easier to hear what I'm saying if this isn't running, but I'm going to be doing all this in parallel. So here's my part, and it goes on this rather oddly shaped fixture here, because I need to drill holes in this face, and this face, and of course none of them are at right angles and none of them have a convenient reference surface. So I made this little drill fixture that will hold the parts in all of the necessary positions over on the Bridgeport. So going over here to the first position, and I don't have my super duper screwed in clamps on the vice jaws. Maybe someday I need to get around to making them, but for right now, I just kind of clamp a little piece of aluminum onto the steel jaws, and works good enough. So there's my first position. I'm going to load up, I've already set the 0 at the standard place at the left rear corner on the vise. Z0 doesn't matter because I'm drilling by eye. It's actually quite a lot easier in some ways to get stuff done quickly if you're not doing that many on the bridge port. So let me load up here. And just kind of eyeballically examine it for sanity checking. And yes, in fact, it looks reasonable, so gonna drill the first hole. And gonna drop the knee down a little bit. Move to the second hole location. And probably move the knee down a little too far. And then for the third hole, I need to change the tool. Of course, I had a vigorous internal debate with myself. What's faster, doing a tool change or doing all of the number 1 drills first, all of the number 2 second, and decided that a tool change made more sense. So that completes the part. Got a little bit of deburring to do. I'm going to finish the surface on the Scotch-Brite wheel. This one's not going in the vibratory polisher because this is a cosmetic part. It's got to look nice, and the brushed finish really does look really nice. So there is the part. Got its holes and looking good. So I'm gonna finish running these guys, and then tomorrow comes the really complicated one. So thanks for watching. It's been fun.